Good afternoon, and thank you for joining today. My name is Derek Townsend, and I'm a Cloud Solutions Architect with TierPoint. I am here to discuss with you achieving security best practices in public cloud, chiefly Azure and Amazon Web Services. I would like to now discuss the organization that I am with. I work for a company called TierPoint, and we are a data center services provider. We have 43 data centers across the United States, but in addition to that, we also provide professional and managed services for both AWS and Azure environments. The first topic I would like to discuss is the public cloud shared responsibility model. This model is a framework that outlines the security obligations of both the public cloud provider, in this case Amazon Web Services, and their customers. In this model, AWS is responsible for the security of the cloud, meaning they handle the infrastructure, hardware, software, and networking components. On the other hand, customers are responsible for security in the cloud, which includes safeguarding their data, applications, and configurations. This approach allows both parties to focus on what they do best while still ensuring a comprehensive security environment. AWS provides tools and services to help customers meet their security responsibilities. One of the key components of any environment, but in particular public cloud, is identity and access management, which includes strengthening authentication and managing access effectively. It is important to utilize strong authentication mechanisms. It is important also to use complex passwords and to regularly update security certificates. When able, it benefits an organization to utilize SAML or OAuth authentication as well. Role-based access control is a feature of public cloud environments, and it's important to define user roles carefully and to assign minimum necessary permissions for a user to perform their job. As a result of this, it is also important to regularly audit role assignments. One of the key features of public cloud environments is multi-factor authentication. It's important to always enable multi-factor authentication for any administrative account and also to encourage or enforce MFA for all of your users. When necessary, you can utilize a hardware-based token. I would say the key takeaways of these IAM features and functionalities is that strong authentication and fine-grained permissions are essential for robust cloud security, and that MFA significantly enhances user authentication and should be standard practice. I'd like to touch on the technologies that are involved in both AWS and Azure also for managing identity and access management. The name in Amazon is pretty straightforward. The service itself is called AWS IAM. It helps to control access to any resource in AWS and allows for one to manage users, groups, and permissions within one or more AWS accounts. It also provides features such as MFA, which we had mentioned earlier, identity federation, and access control policies. On the Azure side, we have Azure Active Directory, and this is a cloud-based identity solution created by Microsoft. It has features as well, like multi-factor authentication and single sign-on, and also utilizes role-based access control. It can also integrate an on-premises Active Directory controller with cloud-based applications, and it supports various protocols, including OAuth, SAML, and OpenID. Network isolation and segmentation are crucial in public cloud environments for several reasons. Chief among these are security. By isolating networks, one can limit the attack surface area. If one segment is compromised, the impact can be contained, making it harder for attackers to move laterally across the environment. Regulatory requirements also often mandate that sensitive data is isolated from other types of data, and network segmentation can help achieve this. Smaller segmented networks also are easier to monitor, manage, and troubleshoot. In addition to this, AWS security groups and Azure network security groups serve similar purposes but are part of each of these different cloud ecosystems. Both act as a virtual firewall to control inbound and outbound traffic to network interfaces, VMs, and other resources. Security groups are stateful, meaning that if you allow an incoming request from an IP, the response is automatically allowed regardless of the outbound rules. Security groups typically are associated with elastic network interfaces on the AWS side and can be applied to multiple instances, and they are typically also scoped to a VPC specifically. On the Azure side, these are also stateful security groups, but they will allow you to assign priority to rules. And they come with a set of rules that can be overridden by creating additional rules with higher priority. And these are typically associated with subnets or a network interface and are scoped at the virtual network level. AWS WAF, AWS Shield are both services that protect applications running in AWS. WAF, which is Web Application Firewall, protects those web apps from various attacks by filtering and monitoring HTTP and PS traffic. And they're customizable because they allow you to create custom rules to block, allow, or monitor web requests based on various conditions like IP addresses, HTTP headers, and so on. And they also integrate with other AWS services. AWS Shield itself was designed to protect against distributed denial of service or DDoS attacks. And Shield provides additional security against larger and more sophisticated attacks, in addition to offering a 24/7 DDoS response team at AWS. Azure Sentinel is a cloud-native security information and event management platform that collects data across users, devices, applications, and infrastructure, both on-prem and across multiple cloud providers. It'll use AI and analytics to identify security anomalies and potential threats, and it allows for automated responses to security incidents. These services are essential for enhancing cloud security, offering various levels of protection to meet different organizational needs. Encryption is a critical aspect of security in public cloud environments for several reasons, chiefly data privacy, compliance, data integrity, and access control. Encrypting data ensures that even if unauthorized access occurs, the data remains unreadable without a key. Many regulations like GDPR, HIPAA, and PCI require data to be encrypted both at rest and in transit when stored in public cloud environments. Encryption mechanisms can help verify that data has not been tampered with, preserving its integrity. And coupled with proper key management, encryption helps to enforce access controls. Only authorized personnel with the correct decryption keys can access the data. Encryption protects sensitive information from being exposed in shared or multi-tenant cloud environments. And in the event of a data breach, encrypted data is significantly less vulnerable, as it would require additional computational efforts to decrypt. By employing encryption strategies, organizations can significantly enhance the security posture of their data and applications in public cloud environments. Classifying data and sensitive information in public cloud environments is important for several key reasons. Security being the chief reason. Knowing which data is sensitive helps in applying appropriate security measures like encryption or access controls to protect that data. In addition to that, we have compliance, which we had mentioned earlier, resource allocation regions. Not all data requires the same level of security. Classification allows you to allocate security resources more effectively, focusing on the most critical data. Access control, classification guides who should and should not have access to particular sets of data, reducing the risk of unauthorized access. And obviously auditing and monitoring. Classified data can be monitored more closely for any unauthorized access or suspicious activities, helping in quicker incident detection and response. Knowing the importance and sensitivity of data helps in making decisions about its storage, retention, and eventual deletion as well. Proper classification of data and sensitive information is foundational for a robust security posture and effective data management in public cloud environments. Data loss prevention is critical for safeguarding sensitive information across your organization's cloud infrastructure. In Microsoft Azure, the cornerstone solution is Microsoft Purview, which offers unified data governance and comprehensive DLP capabilities. Purview automatically discovers and classifies sensitive data across your Azure estate, on-premises databases, and multi-cloud environments. It uses advanced pattern matching and machine learning to identify over 200 predefined sensitive data types from credit card numbers to healthcare records. On the AWS side, Amazon Macie serves as the primary DLP service, using machine learning to automatically discover, classify, and protect sensitive data. Macie excels at recognizing personally identifiable information and can continuously monitor S3 buckets for sensitive data exposure. To implement a robust data loss prevention solution, follow these key steps. First, identify and classify your sensitive data using automated scanning tools. Second, implement strong access controls through role-based permissions. Third, encrypt data both at rest and in transit. Fourth, set up automated alerting for potential data breaches or policy violations. And finally, regularly audit and monitor your DLP policies to ensure they evolve with your organization's needs. For maximum protection, consider implementing both preventative controls like encryption and access management and detective controls such as activity monitoring and anomaly detection. Regular employee training and clear data handling policies are also essential components of a comprehensive data loss prevention strategy. Aligning public cloud security with regulatory standards involves several steps and best practices. Firstly, it's important to identify applicable regulations that apply to your organization, such as HIPAA or PCI. It's also important to conduct a gap analysis to assess your current security posture against the requirements of the regulatory standards to identify gaps. As we had mentioned in a previous slide, data classification, encryption, and access control also factor in to your overall strategy for aligning public cloud security with a regulatory standard. Documentation is important, obviously, for auditing reasons and maintaining an audit trail. Maintaining detailed audit trails of data access or modification are often required for audits, and conducting periodic security audits and risk assessments ensure ongoing compliance and identify areas for improvement. Lastly, developing and maintaining an incident response plan that aligns with a regulatory requirement or standard is significant and also required for reporting and mitigating security incidents. Many cloud providers offer tools to help maintain compliance. Among these tools are services such as Azure Policy, Azure Blueprints, AWS Artifact, AWS CloudTrail, amongst others. By taking a comprehensive and structured approach, one can effectively align a public cloud with the security measures that apply to their vertical or sector, therefore reducing risk and ensuring legal compliance. In both Azure and Amazon Web Services, threat detection operates through two complementary frameworks: Cloud Security Posture Management and Cloud Workload Protection Platforms. In Azure, Microsoft Defender for Cloud provides CSPM capabilities in its free tier, continuously assessing security posture, while its paid plans deliver CWPP functionality for runtime protection of specific workloads. AWS approaches this through a combination of Security Hub and Guard Duty. Security Hub handles CSPM functions, managing security posture and compliance, while Guard Duty alongside AWS CloudWatch and AWS Config provide CWPP capabilities for real-time workload protection. For data-specific protection, Azure CSPM monitors storage configurations and access patterns, while its CWPP features detect and respond to runtime threats against databases and storage services. AWS Macie enhances these capabilities with machine learning-based sensitive data discovery, while Guard Duty's CWPP functionality monitors for suspicious data access and potential exfiltration attempts. The key difference lies in integration. Azure excels in hybrid environments with strong Microsoft ecosystem integration, while AWS provides deeper integration with its native services. Both platforms offer comprehensive threat detection through the combination of CSPM's preventative controls and CWPP's runtime protection, creating a robust security framework for enterprise cloud data. Both AWS and Azure offer a wide range of security services designed to help organizations protect their cloud-based assets. On the AWS side, we have IAM, Shield, and WAF, which we've already discussed. In addition to those services, we also have Amazon Guard Duty, which is a threat detection service that continuously monitors for malicious activity. AWS CloudTrail, which logs API calls providing a history of changes to resources, and Security Hub, which is a centralized view of security alerts and compliance statuses. On the Azure side, we have Azure Key Vault, which stores and manages sensitive information like keys, secrets, and certificates. Security Center, which is a central hub for monitoring and managing the security of resources. Sentinel, which we've previously mentioned. Azure Firewall, also, which we previously mentioned, which is a stateful firewall service. Azure Policy allows an organization to set requirements and enforce those requirements for any sort of resource that exists within a subscription. And Azure Monitor, which is a collector that analyzes and acts on telemetry data from Azure and on-premises resources. Both AWS and Azure offer comprehensive sets of security services designed to address various aspects of cloud security, from identity and access management to data protection and threat detection. Embedding security into DevOps processes, commonly known as DevSecOps, is particularly crucial in public cloud environments. Here's how an organization can achieve scalable protection. Using infrastructure as code templates to define cloud resource configurations ensures that they are consistently secure by design. Tools like CloudFormation, ARM templates, and Terraform help to achieve this end. Integrating security scanning tools into the CI/CD pipeline to automatically scan code and cloud configurations for vulnerabilities is also important. Services like AWS Code Pipeline with built-in security checks or Azure DevOps with Azure Security Center can help. If you're using containers, ensure that they are scanned for vulnerabilities. Solutions like AWS ECR or Azure Container Registry offer integrated scanning. Automatically validate that the infrastructure that you're creating follows compliance requirements utilizing services such as AWS Config or Azure Policy. It's important also to establish feedback mechanisms between security and DevOps teams to continuously improve security postures. By integrating these practices into DevOps processes, organizations can ensure that security is not a bottleneck, but an enabler of faster and safer software delivery in public cloud environments. Disaster recovery in public cloud environments is critical not just from an availability perspective, but also from a security standpoint. Data protection is a key item as a part of this. In the event of a cyber attack, such as ransomware, data corruption, a robust DR plan can allow organizations to restore from a clean backup, ensuring data integrity and availability. In addition to that, it can be used to mitigate a DDoS attack, provides for quick incident response, and also allows for isolation and investigation in the event of a breach. Compromised systems can be isolated and traffic can be rerouted to DR environments. In addition to that, many regulations mandate that organizations have a DR plan in place to protect sensitive data. Cloud-based DR solutions also offer the flexibility to simulate disaster scenarios, allowing organizations to test their security protocols in a controlled environment without affecting production systems. In essence, while DR is typically associated with business continuity, its importance to security cannot be understated. A well-designed DR plan in a public cloud environment acts as a safety net, ensuring that organizations can swiftly recover from security incidents while minimizing adverse impacts. Security updates and patch management are essential in public cloud environments for several key reasons. Chief among those are vulnerability mitigation and compliance. Software inevitably has vulnerabilities, and regularly updating and patching your cloud services and applications help to close those gaps before they can be exploited. Many regulations like GDPR or HIPAA require up-to-date security measures, which often include regular patching. This helps to reduce the attack surface area. Often outdated software becomes a target for cyber criminals. By applying updates and patches, one minimizes the attack surface. In addition to that, a security breach due to outdated software can significantly damage the reputation of an organization. Keeping systems updated shows a commitment to customer data security. In addition to that, organizations that maintain a robust security posture by staying updated are better positioned to compete in the marketplace where consumers are increasingly concerned about data security. Both AWS and Azure offer their own security update and patch management systems, chiefly AWS Systems Manager and Azure Update Management. Leveraging automation tools can be important as well to schedule and apply the patches. In addition to that, monitoring patching status is crucial to ensuring that all of the affected systems are updated in a timely manner. Wanted to touch briefly on some lessons learned from past security incidents in both AWS and Azure. Some of these items include unsecured AWS S3 buckets. These expose customer data, and that can often lead to issues or hijacking in some cases. The mitigation plan for this is implementing bucket policies and utilizing AWS config for automated compliance checks to ensure that it's meeting the requirements. In addition to that, oftentimes Azure SQL databases can be exposed where they're publicly accessible, have a public endpoint. A mitigation plan for this is to deploy Azure Firewall and configure proper network security groups to limit access to these SQL servers. In addition to that, oftentimes we will see denial of service attacks from other regions on customers within the United States or elsewhere. These manifest themselves in sustained DDoS attacks. We can utilize services such as Azure DDoS protection for network layer security in these events. And finally, for brute force intrusion, oftentimes actors can get unauthorized access through an open SSH port on a virtual machine. It's important to close those ports and implement something like AWS WAF for real-time application layer protection. Thank you all for joining today. We hope you found this presentation helpful. If you'd like to speak to someone about your cloud needs, you can reach us at www.tierpoint.com or sales@tierpoint.com. We have also listed our phone number on this slide as well. Thank you again and have a good day.